pair deck?
It is always on a pair deck. So if you wanted, like my slide, you could join the pair deck. But for Bellwork today, we've got 3 problems. You need to find the graphs of these 3 using Desmos or whatever. I'll give you 3 minutes to do it, and then we'll go over it.
Oh, Madison never gave it back to me. You know, those tools that have to be for independent study.
Well, to be honest,
They're not even important.
we'll see if they use it. I'll talk to them. I think they might use the web assigned videos instead because they're shorter.
Burger's probably super good. Wait, Burger's the
Laurel and Bethany. Mhm. I need the lights up. All right, let's go over it. So you could graph this in your TI-84 or Desmos, but if you remember, the parent function looks like this, passing through the points. I should probably label these 0, 0, 1, 1, and -1, -1. Then we could graph the rest of these by hand, actually pretty quickly. What is this negative in front of the X do?
Makes it negative.
Makes what negative?
Those lines.
It flips it.
That's what I
Makes
said.
your negatives positive and your positive negatives,
I mean, that's
right?
what I said, basically.
Flips it. That's, I mean, basically.
Yeah.
It's so many words.
That's what I implied.
Sure. So we just got to flip it. So it'll look like this. Isn't that kind of cool? It's an hourglass, kind of. All right, next one. If you add 1 to your function, what does that do? It does not, Jacob. No. Kyle? Up 1. So then this goes to here. This goes to here. And the last point goes to here. Well, I probably should have labeled that one. That's h of x. The other one was g of x. Okay, and the last one, what color do we want? Purple? Perfect. All right, what does the -1 do? Moves it to the right. Yeah, moves it to the right one. It is always a trick question with that one because it does the opposite of what you would think. That one moves it to the right one. Isn't that a lot easier than doing it in Desmos? Just know your transformations. You two remote people can't see, but they're all nodding right now. So a few in the back are applauding. That's true. Now all of them are doing it. Questions on the bell work? Okay, then today we're going to do 2.2, which is polynomial review. You have done this before. There are 4 things we need to do. We already did the first one. Boom. Use transformations to sketch graphs. Good job, you. Then we're going to do the leading coefficient test. That one's not too bad, in my opinion. Finding zeros. That one is kind of bad. And then intermediate value theorem. That one's not too bad. So it'll be easy and then some hard stuff. I have a feeling, in fact, did I already do it? Yeah, I have a feeling that this lesson is actually going to take 2 days. Now, the weird part about that is the next time we meet is on Wednesday next week after you have tested all morning. So I'm going to try my best to get all the lecture done here so that Wednesday is just a work day. But if we fall short, anything I don't cover will happen on Wednesday. This homework that is not due till Friday next week. We have forever to do it. All right, the leading coefficient test. So the leading coefficient test will, I'm going to put something on here in addition to what's already on the slide, just a little table. But basically, for any, wait. Did I give you the definition? I gave you the definition of a polynomial last time. Okay, so if you remember, any polynomial can be written in terms of a coefficient x to a power plus another coefficient x to the power. The degree n is the largest power in the polynomial. So for example, if we had f of x was, I don't know, 3, x to the 5th minus 4x squared plus 10. This polynomial would have a degree of 5 because 5 is the largest power. Another example. Let's say g of x was 12x minus 8x to the 10th plus 2x squared plus 9. That one would have a degree of 10 because 10 is the largest power. All right. So the leading coefficient test will tell you what happens as your x goes to positive infinity to the right, or negative infinity to the left. What happens at very large values of x and very large negative values of x? What will happen will depend on the degree of your function. If the degree is odd, there are 2 cases. It's either going to look like this. So as you go to positive infinity, y will go to positive infinity. And as you go to negative infinity, y goes to negative infinity, or it'll flip that. As x goes to negative infinity, it'll go to positive. And when x goes to positive, y goes to negative. What determines which case you use is whether or not your lead coefficient is positive or negative. In this case, the coefficient with our highest degree is 3. So our lead coefficient would be 3. 3 is a positive number, so f will look like this one. If that was a -3, then we would do that. For this one, again, your lead coefficient should be, if it's in the correct order, should always be the first term, but sometimes they'll try to trip you up like this one where we put the highest degree in the second spot, which again is not proper notation, but they'll do that on the ACT just to see if you really know what your stuff. The lead coefficient is really still -8. It is the coefficient that is with your highest degree. So this one is going to look like this. If n is even, y will go to positive infinity no matter what, as you go to the right or left, like a parabola, or it'll both go to negative infinity. And what determines whether or not it goes up or down is whether or not your lead coefficient is positive or negative. In this case, it's negative, so this would be the case for g of x. As x gets really big, y goes to negative infinity. As x gets really big with negative numbers, like -10,000, -10 million, y goes to negative infinity. Also, just as an aside, before we move on and do another example, this gives you a set of really good dance moves for the prom. If you ever need those, you just follow the behavior, go like this, and then like that, and then like that, and then that, and just do that over and over again. People like it. It'll catch their attention, right? No, you should do it and record it, and then let me see that.
Just to see our.
So, because I want to be impressed. It'll be so impressive. Like, wow, they're really doing that. Wow, I can't believe they did that. All right, questions on this? Okay, let's do an example. So, for example, if f of x is -x cubed plus 4x, to do the lead coefficient test, we need to know two things. First, what is the degree? Three. The degree is 3, which is an odd number. What is the lead coefficient? -1, which is a negative number. Yes, you probably don't need to write that. All right, so if it's odd and negative, then what it looks like is this. And again, what happens in the middle could be anything. This one will kind of look like this. Something like that. But the end behavior is what we care about. As x goes to positive infinity, f of x goes down forever to negative infinity. And as x goes to negative infinity, f of x goes up forever to positive infinity. And again, how I got these answers is by classifying it and then looking at my notes. There's only 4 cases. N is odd, so it's one of the top 2. Lead coefficient is negative, so it's that case. Let's say you're taking the ACT and ask you a question about this and you do not remember the test. What is an easy way you could just check this answer really quick? I mean, you could graph it, but even easier, you just plug in 1,000,000 or 10,000 and see what the answer is. If you do -10,000 cubed plus 4 times 10,000, the answer is -9 times 10 to the 11th power. That's negative infinity then, right? You just check a really big number and see what you get. You can also graph it. I mean, you got a TI-84, right? The only thing I'll say about graphing is you have to adjust the window then, because sometimes you have to zoom out to really see what's going on. Yay? Are you ready to try this on your own? You want me to make up another problem before you do that? No, okay, all right, that's fine. I didn't even want to make up another problem. All right, try these two. I'll give you 3 minutes and then I'll call on the 2 people that look like they would have the most fun answering. I'm gonna walk around. If you need any help, just stop me. Also, I put the little table up here on the thing. That is, your leading coefficient is the one that's in front. First, not the biggest. This is the one that's in front. So whichever one you have degree coefficient. Degree is even, lead coefficient is positive, so it's like a parabola. Yeah. Oh, so that'll be plus 50. Okay. This one is, oh, that's good. Okay, so what's the degree of that one? Highest power, 4, and the lead coefficient is 1. So this is even number of positive coefficient. So then that is even positive. So always, no matter what happens, that's more than both directions. So how you want to write that is your answer will kind of look like this over here. You'll just say that. Yeah. All right, let's go over it. Okay, so I'm looking out here. Who's going to have the most fun answering this? I know who it is. It's someone who gets called on randomly. He just left. What is that? Shenanigans, I say. We'll get him when he comes back. 4-2. Max. All right, Max, what is the degree of this function?
4.
I don't want to do that. Yes, 4. That's right. What is the lead coefficient?
1.
All right, so we have an even degree, positive. So as x goes to infinity, what happens to y? Hot dog. What about if x goes to negative infinity? Whoa. Cool. It'll look like a parabola. Again, some stuff might happen in the middle here, but when it gets really big or really small, it's going parabola.
Is it not y?
No, because it's even. So that's this case. Oh, shoot, I messed up. Is that possible? No, I didn't. It was just a scratch. I know it looked like that was a negative infinity. That was just a scratch. That probably applied here somehow. Hit the monitor. Yeah. All right. Next is 3, 3. Tristan. All right, Tristan. What is the degree of this function? 5. What's the lead coefficient? Suspicious that they're both 1, isn't it? Well, that's okay. So now we're odd. Our lead coefficient is positive. So if x goes to infinity, what happens to y? Yay. What about if x goes to negative infinity? That's perfect. Well answered. Yay. Questions on this? Do you want to do another one? No. All right. Anybody need more time to write? A little bit? I think for the next painting, by the way, since we got these weird weeks, I'll bring it in Wednesday, but then I'll draw for it the next Wednesday. I did. Cole Rodriguez, which is actually kind of appropriate. He was the one that gave me the idea. He said I should just draw. Hey, you were called on right when you left. But that's okay. It'll come back to you.
Come back to you.
All right. Oh, Jake. Oh, sorry. Was that anybody need more time to write? Okay. Do. All right. Next thing that we got to do is the zeros. So now this is the part where it starts to get a little complicated. I will tell you at the end of the day, you can always find the zeros by graphing and looking for your x-intercepts. So if you're ever not sure how you could solve it algebraically, you can always just graph it and get an x-intercept. The other thing that's tricky about this is there are so many synonyms for what it's asking for. If it asks you for a 0, that is the same thing as a solution, which is the same thing as saying that x minus a would be a factor, which is the same way as saying that that number is an x-intercept, which is not written on here. That's also the same thing as roots. So on the ACT, if it asks you for any of those 5 things, it's asking you actually for the same thing. What's the x-intercept? What's the solution? 0, roots, factors, all of those are the same thing. What values of x make our equation 0? And then the factor is just written as that minus a. Would that mean factor? Anybody need more time on this slide? Okay, so to solve this, again, there are multiple methods you can do. The first method you can do, I will not show you because I'm pretty sure you can do it, is you can just graph it. Type it into your TI-84, type it into Desmos, and what you're looking for are the x-intercepts. To solve this algebraically, what you will need to do is factor it. To factor this, the first thing we're going to look for is our greatest common factor. What do all 3 of my terms have in common? They all have an x. So I can rewrite f of x as x. And then what I would have left is x squared minus x minus 2. You can always double check that step. If I multiplied this back in, x times x squared is x cubed, x times negative x is negative x squared, x times negative 2 is negative 2x. All right, this is now fully factored. I have just an x. In the parentheses, though, that is a trinomial, which I could factor some more. Or once you get it down to a quadratic, you could do the quadratic formula. X is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. But this is probably faster done by factoring. I know the first term on each factor will be x. X times x is x squared. Does anyone remember, how do I find the numbers that go here? I need 2 numbers that and add to -1. What are two numbers that multiply to -2 and add to -1? -2 and +1. -2 times 1 is -2. -2 plus 1 is -1. And again, the nice thing about factoring is you'll know if you did it correctly. You can just multiply those back out really fast and see. I'm going to write it. You don't have to write it. But if you did that, you get x squared plus 1x minus 2x minus 2. 1 minus 2 is -1. Yay. Okay, so that is how I could rewrite f of x. And now if I'm looking for zeros, I'm saying what values of x will make that equation 0. And the nice thing about it being factored is if any factor is 0, it'll make the equation 0, right? Because 0 multiplied by anything is 0. So x could be 0. Or what would make this 0? 2. X could be 2 or -1. Those are my zeros. And again, if that messed you up, you should actually probably ask me for help and we could do some of those because that's a big deal on the ACT is solving by factoring. But you could also graph it. You could graph it. Anybody need more time on this example? Okay, your turn then. Do this one. Try it by factoring first. If after 2 minutes you are still stuck, graph it. I will call on one person who got skipped out earlier from being called on. Whoever that is. The dice must be obeyed. Oh, I should have said this at the beginning of the class, but I'm a bad teacher, so I forgot. You all will need to audit your grade if you ever turn in anything late and did not notify me. WebAssign does not notify me at all once you have completed something late. So you asked for an extension and I gave it to you, it never tells me if you did it. So if you did something from an extension, make sure it's in Tyler. And if it's not, let me know and then I'll put it in Tyler. Probably not, only because it's due at midnight. So I won't be able to grade all 22 of yours between 11:59 and 12 and midnight. And the quarter ends today, so. You don't come to school on Monday. I mean, technically, I guess I could add it in Monday. I probably won't. No, it'll go in the second quarter. Not that it really matters, because I mean, your homework is a very small percentage of your grades, but. Monday, yeah, no school Monday or Tuesday. But no, we'll meet Wednesday for that like 40 minutes after you've been tested all morning. What's this?
I only get 40 minutes of my off class, and I gotta spend an hour and a half in that class.
Why not, girl? I got
McDonald's. I said, like, I don't understand. It's just McDonald's. Don't see the G there. The G sounds like just like, wow.
I have to stay there all day.
I don't understand why you guys don't understand.
Okay,
Well, yeah.
let's call on somebody randomly to help us with this problem. It is lucky person. Oh no, I went to a different screen. It's Jacob. Jacob.
No, don't do me again.
Hold on, I didn't do that right. I clicked the wrong tab. All right, lucky person number. Oh, it's Jacob. Okay, Jacob. What's the first thing I gotta look for is what do they have in common? What do all three terms have in common? That's right. So if we factor that out, we're left with this. Okay. I can factor one more time, the quadratic. X and X. All right, what numbers should I put here? Close. You have the right numbers, but I believe the 3 should be positive and the 2 should be negative. Because that way 3 times -2 is -6, and then 3 plus -2 is +1. But maybe you're ahead of me. Maybe you're telling me the next thing. If I want to make these zeros, oh, no. Oh, shoot. No, that's right. That's right. If I want to make these zeros, X will be 0 when X is, or sorry, the equation will be 0 when X is 0, -3, and +2. Yay? Okay. Really quickly, I know we probably know how to do that in Desmos. Do you know how to do that in TI-84? Let me show you. Boop, boop. Oh, no, wait. Hold on. Is this going to work? I'm going to have to reshare our whole screen. Okay, stop share, reshare, whole screen. All right. Y equals x cubed plus x squared, oh sorry, x to the third plus x squared minus 6x. Enter, graph, nope, zoom. Oh, do you know about this trick? If your window is ever messed up, you can hit zoom 6 and it will give you a standard window. Zoom 6. And then to get your zeros, you hit second trace. That'll bring up your calculate for your graph. And option 2 is your zeros. And then you just follow the prompt. So this one, 0, 0, is just give it to you. But if you go left of where you think a 0 is, hey, Carter. And then right of the 0, and then hit enter, boom, it'll give you the other 0.
I just wanted to see what my test was.
Oh, yeah, I probably should do that.
Okay, because I was talking to the other people in the class, and they're like, we all
That's
got
true.
our grades back.
I'll probably grade it during passing period or the next guy to practice thing. It'll be graded before 8th hour.
Okay.
Definitely. All right. So for many of you, ACT on Wednesday, that's how you could get zeros of a graph. Or a solutions, roots, the factor would then be x plus 3. You can get a lot of that information from the graph. Because all of it is really the same thing. Okay, I remember getting asked this question a whole bunch last year from Honors Algebra 2 students. So I know you've covered it, though maybe not well. Repeated zeros or multiplicity. If x minus a is a factor multiple times, then you could write x minus a as a power of some number like k. in which case a is a repeated zero of your function. Whether or not your power is odd or even determines the behavior of the graph at that intercept. If k is an odd number, then the graph will cross through at that intercept. And if k is an even number, then it touches and turns at that intercept. Remember seeing that before? No? Well, that's okay. I'll show it to you. I'll show it to you again. It gives you some time to work.
We heard you talk 2 hours the first day.
That, well, yeah,
I still like to talk.
I do like to talk. All right, any more time on this slide? All right, let's see it in action. You just want to see it in action. So let's say we have a polynomial function who has zeros, -1/2, 3, and 3. We can write that and determine the behavior of the graph. Notice that these two zeros are repeated. 3 is a 0 2 times. So for each of these, I can write each of these as x minus a, where a is then the different numbers here. So f of x could be x minus -1/2, x minus 3, and x minus 3. Those are the factors of my polynomial. There are a few things we could clean up. This becomes x minus 3 squared. Minus a negative is really positive, right? So then this could become x plus 1/2. The other thing that you can do is if you don't like fractions, you could rewrite this as, or like that. Multiply everything in the factor by the denominator, and then you won't have a fraction anymore. So you could do either one of these two. Yes, it will accept both, I believe. If it doesn't, let me know, and I'll talk to somebody about it. Okay. All right. So what this means is for this graph at -1/2, which would be like right here, we have a degree or a power of 1, which is an odd number. So it's going to cross through at that point, like that. And then at 3, my other 0 has an even power. So at that point, it will touch the x-axis, but then turn back like it's scared. So actually, I think this is supposed to go the other way because I think our lead coefficient is positive. So it should, hold on, I'm going to fix that. Otherwise, it'll bother me forever. It'll really look like this. Not that that's the point. It'll look like that. And here, degree is odd, so it crosses through. Here at 3, the degree is even, so it touches and turns. Yay? You ready to try one? This might be the last thing we have time for today. Let's see. Oh no, we got to sketch the graph. We got one more. Oh yeah. All right, try this one then. I can. In fact, I will. Yes, that's right. email me. Say, hey, I did that one. It's a website. Does anyone need more time? Okay. Okay. I guess, I don't wanna. I don't think we're gonna have time for the, well, that's okay. I'll make the example bell work. That's fair. I'll make it bell work. All right, this will be the last thing we do. Theoretically speaking, if someone wanted to go to Topeka for a jalapeno cheddar bagel, is there any places left that still sell that? A jalapeno cheddar bagel.
Are you saying like to buy like a bag?
I want to have one. Pizzagles? Do they got one? Oh, wait, maybe. I don't want this hedging. Panera used to have one. That was great. They don't have it anymore. Dylan's used to have one. They don't have it anymore. Pizzagles? Okay.
Oh, wait, you said Panera doesn't have any?
Panera used to have it. It was great. We'd have bagel Fridays or donut Fridays. People would bring in. You had to be the first one to the lounge to grab the jalapeno cheddar bagel. Otherwise, Bear would grab it.
Who keeps that long John Silver's open?
Ew, absolutely.
Who keeps
I
that
wanna
long
know
John-
who keeps it open. It's probably Mr. Bear, let's be honest.
Mr. Bear is a long John Silver.
All right, you know what? It would have been right if we ended class without calling on. Oh, yeah. All right, how should I write this function? Perfect. Yay? Yay? Perfect. And then we can combine the x minus ones together, right? There are two of them, so it's x minus 1 squared. If you wanted to graph it, its graph would kind of look like this. I know it's going to end up like this. Don't ask me how I know, but I just know. At -2, it's going to cross through because that one has an odd power. At +1, it'll touch and turn. And then at +2, it'll cross through. So that's what the graph will look like. On Wednesday next week for bell work, we'll go through how did we know the end behavior and like put all the content we've had together. That's right. We don't have to. We get to. That's the can-do attitude I like from you, Tristan.
Yeah.
Yeah.
That's what I was.
That's what you're saying. We don't have to. We get to do that.
Yeah. You
All right.
read my mind basically.
The whole picture is messed up.
18.
Is there anything else I was gonna say? Oh yeah, as a reminder, the homework's due 7 days from now.
7 days from now?
Yeah, not this Friday, not today, but next Friday. That one's to do today.
Oh, shoot.
You should do that
I
one.
better keep going.
Yeah, you should do that one.
How many questions are on one? I didn't start it.
I don't know. I can check though.